Okay, welcome everyone. Sunday, another cool stream. Planning for today to continue our roadmap. So let me show you the roadmap which we are using. We use this site called leetcode.io, and the trick here, we'll need to follow this roadmap of solving problems. Yeah, let me zoom it a bit. During the last stream, we solved all these 5 problems, and we have like 4 more to solve. I guess 3 more, because this will be a premium link. So unfortunately, or fortunately, I do not pay yet premium for leetcode. Maybe in the future I will. So I do have my cup of tea prepared, and I'm ready for another session to learn and grind my algorithmic skills in rustlang. Okay, so let's first check all the things here. Checking if the stream works fine. Moment. Okay, so it looks like I'm live. Very nice. Okay, so this seems to work. Let me put my device here for this to sit. Hopefully it will not drop. Okay, I guess we are ready to move to another problem. So this one would be product of array except solve. So let's see what this stuff does. So we have a medium kind of problem, product of array except solve. Given an integer array nums, return an integer answer such that answer of I is equal to the product of all elements of nums except nums I. That's an interesting one. So given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums of I. So the product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. You must write an algorithm that runs in O of n time and without using the division operator. That seems interesting. Yeah, because I think a way to do this in O of n time with division would be like first time I just multiply everything, and later on I will just divide this by this number. So assuming 1 multiplied by 2, it will be 2, 6, 24. I mean 6 multiplied 2 by 3 will be 6, and 6 by 4, 24. And then I'll be dividing 24 by 1, by 2, by 3, and by 4, and I'll receive these numbers. So this will be like a simple solution. But they deny us to do this, so we need to find another kind of a solution for this problem. Okay, and that's interesting. Okay, the product of any prefix is guaranteed to fit in 32-bit integer. Can you solve this problem in O of 1 extra space complexity? The output array doesn't count as extra space for space complexity analysis. Okay. Yeah, pretty challenging one though. So we're not allowed to multiply everything and then divide, because that would be my solution to go. So yeah, probably let's go to our white dartboard. And we will try to brainstorm a bit. Maybe we'll come up with some algorithms and ideas. Yeah, let me copy this to inputs. What? Okay, so some weird. No, I don't want this. Yeah, let them be here. So does it work? Yeah, it does. So we have some constraints. First constraint is the time complexity should be of n, because obviously if we go with a base scenario, how would I solve this? I would pick every item and then multiply all the remaining. So this can be done, I guess, with 2 for loops. So first for loop, I'll be traversing the items, and the second for loop, I'll be multiplying all the elements. But this will be big O of n square. So this solution is not good for us. What else can we do? If we go backwards, can we do some sort of prefix multiplication, like we do have like prefix sum, prefix multiplication? That's pretty interesting though. Wait, and how did we get 0 here in output for the second example? That's interesting, because -1 multiplied by 1 minus 1 by 0 is 0. Okay, so if you have a 0, then everything will be a 0. So if you do 0 divided by -1, it will be 0 again. Okay, that's fine. But how did we get to 9 then? Okay, because we remove this item, so we'll not need it anymore. So it will be -1, -3 will be 3, and then -1 multiplied by -3 will be just 3, and then we'll multiply by 3 will be 3, and we multiply by 1 and we receive this number 9. Oh, that's really challenging. I do not have a lot of ideas how to tackle this problem. Yeah, let's check the hints. Maybe we do topics. So it's a prefix sum. So we'll need to look for a prefix sum. Do we have any hints? I do not see hints here. Yeah, let's see how can we manage with the prefix sum. Okay, we cannot do division though. But why would we need to? Okay. Yeah, extra space. Okay, so let's try with the prefix sum. A prefix sum would be like we'll need to store the results in such a manner that, for example, first item will be 1, second item will be 1 multiplied by 2, and this will be 2 again, but this one will be 2 by 3, and this will become 6 already, and the third one will be 24, because we keep on keep on multiplying them, so we can receive this. But does it help us? I didn't see how this can help us. So I mean, if we are not allowed to use division, one hack which we can use, we can minus the amount of time which we need to. So that's also a possibility. It's no division though, but it's still it's still pretty cool approach, I guess. So what does it mean, for example, 24 divided by 1? This means how many 1s will be in 24? And how can we do this using... We can do multiplication probably. Maybe if we're not allowed to do this. We may try multiplication, but that would not be of n. Yeah, tricky one. Very tricky one with the constraints. I mean, to solve it, it's an easy problem, but maybe we should go this direction to remove the to transform the division into a minus. So let's assume we've got our product, main product. So we know that the product of everything will be 24 for the first case. Yeah, but for the second, that's a little bit unusual, because for the second case, it will be 0, and this doesn't help us a lot. Because for 0, with the prefix sum, it's very annoying. It doesn't work. Okay, let's try to move on. Maybe we'll find something here. Let's do prefix sum for the second, and let's go backwards. What happens if we go backwards? So let's assume for the first we'll have like 4, then it will be like 12, then it will be like 24, and then it will be like 24. So we have the prefix sum backwards. And if we compare this with our output results, let's put here the output results. I'll also put them in backward order. 24, here I'll have like 12, and then we'll have like 8, and then we'll have like 6. Oh, hello. My favorite student, which doesn't miss any stream. Yeah, not sure how long did you join, but there is a tricky problem I'm trying to solve, and I do not have a lot of ideas. So let me outline again the problem. So the problem in itself, it's quite easy, but there are some constraints which makes it more difficult. Okay, so that's the problem. We have the product of array except self. So imagine this: we're given an array. So like for example, like this. So we have like 1, 2, 3, 4. We'll need to output the product of all the items in the array except itself. So 24 here, because we'll have like 2 multiplied by 3 will be 6, and 6 by 4 this, and it will be like 24. So that would be the product. For this one, 12 will be like everything 1 multiplied by 3 by 4, and this will be like 12. For next one, 8, it will be like 2 multiplied by 4 multiplied by 1 will be 8, and for 6 will be 2 multiplied by 3. So that would be kind of the prefix sum part. So one way to solve this, I mean, pretty easy way, what I was thinking to do, let me clean it up a bit. Simplest possible way to do it in linear time. I just do the product of all numbers. So let's assume I'll have 24. And then I'll divide this number by each number in itself, like by 1, 2, 3, 4. And this will be in all of n time. But for this example, unfortunately, it doesn't work. Because if you have 0, the product of all numbers will be 0. And then I cannot divide 0 by anything because I receive 0 always. So I'll need to think something smarter. So in tags for this problem, it's shown that it's a prefix sum. So I'll try again to look in this direction. Yeah. Okay, so the things here, what a prefix sum is, I'll go number by number, but in our case not be a sum, but it will be like a prefix multiplication. So for first item, let's assume it's something non-defined, and it will be 1. For second, it will be 2 multiplied by 1, it will be like 2. For 3, it will be 2 multiplied by 3, it will be 6. And for last one, it will be 6 multiplied by 4, and it will be like 24. So that would be the prefix multiplication. I call it pref multiplication of this array. If we go for the second one, because it's also interesting, we'll have like -1 in this case. Maybe I should start with 1 probably. We'll have -1 again. For 0, it will be 0, because anything multiplied by 0, it will be 0. Yeah, but this is tricky though, because this 0 mess up completely my my algorithm. Maybe I should skip it. Yeah, probably I should skip it, I don't know. Because if I have a 0, anything multiplied by 0 will be 0. So yeah, anyway, let's try to work this out. Because later on, if we have 0, anything multiplied by 0 will be 0, and it doesn't give us anything absolutely. So maybe I'll keep the biggest number here, -1. And then for -3, I'll have -3 multiplied by -1, it will be like 3. And then for the last one, 3 multiplied by 3, it will be like 9. So I'll have some values in this case, some useful values. But how to use those values to get our output? That's the trick. Maybe I should go in reverse order. Maybe I should sort them. No, if I sort, it will be not big O of n already, so it will be n square or n log n. Yeah, that's an interesting problem. A bit blank though. So if we have this prefix sum, we have like 24, and we see 24, it's our first item because it's 1. But let's imagine, but this was not 1, but okay, so actually if it was not 1, it was a different number in that case. So we have like 1, 2, 6, and 24. And we know that, what do we know? Yeah, this one. Because if you remove 0 from this vector, if we multiply all the other numbers, it will be like minus 1 multiplied by 1, and then minus 3. Yeah, example 2. So minus 1 multiplied by 1 will be minus 1, and minus 3 multiplied by 3 will be minus 9. And if we do minus 1 minus 9, the response will be 9 here. So the trick is, if we do have a 0 in our vector, pretty much everything else would be 0, and we'll need just to count everything else. So I guess for 0 cases, we can choose, we can hard code something like 0 everywhere and the last number here, the remaining. But that's also not correct, because we may have like 2 zeros, and if you have 2 zeros, then there is no option. It will be everything 0. So if it's only 1 0, this would be possible to do. But if you have like 2 zeros, it will be always 0. Yeah, that's a really, really difficult problem. I mean, you'll need to know a trick for it to solve, and unfortunately I do not know. The trick is to use a prefix sum. But how? The question. That's the question. Once again, let's try backwards maybe. So we have like 4, we have like 12, 24, 24. Yeah, I do not see it. Do not see it. So let's assume we need to find the value for first. If we go with the brute force approach, I would skip first item and I'll do multiplication of this range. And I'll receive 24. But if I do prefix sum, so I know in this case that all the numbers, yeah, probably I'll need to so what does this 24 mean? This mean like we have like 1 multiplied, like all 4 values. Let's put it all 4 values. 1 multiplied by 2, by 3, and by 4. So that would be this. 6 will mean everything besides 4, and this will be 1 multiplied by 2 multiplied by 3. This will be like only 1 by 2, and 1 will be 1. So I do have those values. So if I do the prefix sum, I have this number. Yeah, that's tough. I didn't see a solution. It's too tough. What should I try though? What should I try here? Let's check again. Once you're stuck, best option is to go back to the description of the problem and try to see. Maybe there is a hint which we missed. So given an integer array nums, return an array answer such that answer I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in a 32-bit integer. That's useful. You must write an algorithm that runs in big O of n time and without using the division operation. So I think I worked out the idea of division and didn't work. But we can translate, because what division is, it's a lot of minus signs. So maybe we can do a big amount of minuses. So what does, let's say, 24 divided by 2 mean? Because we know that's 12. And what that would be? It would be like how, let's say x. Yeah, I have troubles with basic math now. Looks like. Uh, so how many? Okay, so divided by 2, it will be like how many times I'll need to plus 2's to get 24. That would be like, so I need like 12 2's, and then I'll have 24. So I may try like with a while loop, n being equal 0 or 1, I guess, because we need to get to a number, and then I'll do n n plus 2, n will be equal n plus 2, and I have a counter, and I'll increment by 1, and I will get 12 times. So instead of writing division, I can do this weird while loop. But this increases the complexity because this is not in constant time. So we have another for loop. Yeah, okay, that's tricky. Maybe there is someone in the chat who knows how to tackle this problem. Yeah, let me try again. I cleaned up this. To use a map with recomputed values until current index. Not sure I got it though. If you can elaborate a bit. Computed values. This part I'm not sure I get it. What do you mean by computed values? So this pre-computed, like at index 1 would be, so we have like all these indexes 1, 2, 3. So we have 4 items. So this will be 1. For the first, like here it would be 2, here it will be like 6 and 24. But how we should remove 1? Because for example here, if we remove 4 from this equation, the answer will be 6. Because if we sum everything, this will be, if we remove the last one. If we remove the middle one, if we remove 3, it will be like 2, but we'll need to multiply it by 4 again. So 2 and 4, and this will become 8. Computed values. Yeah, it doesn't ring the bell. Maybe I'm I have like some sort of stupid mode on where I cannot see like anything, just any obvious stuff and things. So you basically loop till the middle and store in dictionary I all multiplication values until current. So loop to the middle. Okay, so I'm looping here. So let's say I have this 1, 2, 3, 4. So I loop till here. Yeah, but that's actually the trouble, because we need it to be in big O of n. So I'll need to traverse it once, or I cannot do nested manipulation. That's the trick. So what I can do, I think, to be it in O of n, I can do like multiple times this for loop. So a constant amount of time. So if you go with the prefix sum, so first iteration, I have this. Maybe I can go with a second time, go with backwards something. So what happens if we go backwards? So maybe that would be an idea. If we go backwards, let's have 4, 12. 4, 12. Yeah, maybe I'll write them in this order. So we'll have like 4, 12, 24, and then 24. So that would be prefix sum in backward order. So what this mean? This mean this 24. This mean the multiplication between 4, 3, 4, 3, and 2. What this number would imply. 12, it will be like 4 and 3. This will be just the last, and this would be everything, like 4, 3, 2, and 1. Because I have these sets. So if I need to form 8 as an answer, if you go in 2 directions, we never need this. That's a given. We never need this, because every time we'll need to remove 1. So this 24 will be minus without the first one. So this value. So if you go this structure, it will be without 1. 4 and 3. 4 and 3. Do we ever need this? I don't think we do. Because here we'll need like yeah, I'm thinking on having like this pre-computed sums. Yeah, but I don't need a dictionary for that. I'm doing here. So when you compute value for, let's say, 3, you look up into dictionary for prev and next value. That's already pre-computed. Wait a second. Prevent next. Okay, so we'll have a big O of n because you iterate till the middle and have a pre-computed values for all position in the array. So I guess we have this sums, yeah. That would be the pre-computed sums or the dictionary part. So we know like index 1 would be this, or actually it will be the last one. So you'll have like a big O of n because you iterate till the middle and have pre-computed values for all position in the array. Yeah, let me check the whole idea again. To use a map with pre-computed values until current index. Okay, so that would be kind of the map, this stuff which I have here. So let's assume I'll write it like this. So for position 0 pre-calculated will be 1. For position 1 it will be 2. For position 2 it will be like 6, and for position 3 it will be like 24. So that would be our map of values. So we did this chunk. So when you compute value for, let's say, 3, so we have this for 3, I guess. Yeah, maybe I shouldn't use the index, maybe I should use the value. Okay, so yeah, probably I should use the value. So for 1 it will be 1, for 2 it will be 2, for 3 it will be 6, and for 4 it will be 24. So we do have this part pre-computed. Or I'm not sure if we did compute it correctly though. Okay, so when you compute value for, let's say, 3, you look into the dictionary, you need to iterate from start and the end at the same time. Yeah, I'm not sure I get it. I mean, it looks like I'm stupid today. I guess next stage you'll write the code and and maybe I'll figure it out. Okay, so let me try back this part. Yeah, I guess let's try to write some code. I mean, we spent like half an hour, more than half an hour, trying to figure this problem out, and it's a no success product of array except itself. Okay, so let's do cargo new product of array except itself, and the number of the problem 238. Okay, so I don't need this, unfortunately. Itself 238. You need to iterate from start here and at the same time. Okay, I mean, cd cargo product itself. Okay, we did set up this part. Let's add our implementation and the test cases and try to code something. Maybe we will move. So we have this part done. Here we'll be adding our scenarios. So let's have this first vector 1 2 4 1 2 3 4, and we have the answer being like, yeah, I'll keep having the copilot for now because this helps to generate a little bit of solutions, which is very helpful. And give me the second, yeah, and it gave me the second. And now let's close it. And now let's close Copilot. Disable completions. So we do have this part. We do have the to-do part here for this to compile. So trying to go with next and previous and next. Yeah, let me go back here a bit. So let's go back here and use 1 2 3 4. So we do have the following thing. We pre-compute stuff. 1 2 6 24. Actually, it doesn't, looks like 29, so 24. So that would be the pre-computed. Now, our solution for position at index 1. We need the sum of 2, 3, and 4. But here, we never have this 2, 3, and 4. We have like the sum of 1, 2, 3, and we have the sum of 1, 2, 3, 4. So we have this option. Yeah, I guess let me move this a bit. We have the option to have this. And we need kind of to divide 24, because we have this. We divide by this number and we'll receive our value. So our value would be 24 in this case. Let me choose another color. So for 2, if you go for 2, we'll need an option to have like 1 2 1 3 4. Yeah, hello Krish Patel. Yeah, welcome. I'm struggling for an hour to solve a problem. I literally have no clue. Another subscriber, Unwari Kare. Can you show the question? Yeah. So that would be the question. Given an integer array nums, return an array answer such that answer of I is equal to the product of all elements of nums except nums I. The product of any prefix or suffix of nums is guaranteed to fit in 32-bit integer. You must write an algorithm that runs in big O of n time and without using the division operation. So they forbid us to do division. So we have example 1. Given this, we have this value. For the second part, we have this value. So this will be the constraints. So not that big, the constraints. So once we figure out how to solve this one, we may go extra step to try to solve it with the 0 extra space. I mean, using some sort of constant operation. And my initial idea was to do, but yeah, I guess I'll get back to my point here. So we have like 1, 2, 3, 4. Do we have this sum somewhere stored? No. Because either we have like, so all of our possibilities are like 1, 1, 2, 1, 2, 3. I mean indexes. And 1, 2, 3, 4. So we can manipulate with the sum of all elements. So 24 here. So 1, 2, 3, 4 will be exactly this without 2. So looks like this approach, it's not helpful. Not at all. We need something else. Need something else. Yeah, I do not see it, guys. I'm blank. We need something else. So some sort of other prefix, sum. So multiplication. I guess one way on how we can do this would be like try to use this number and to get out of this number this number. Wait a second. So what would be like 1, 2, 3, 4? It's expected to be 12. So we have this and this, and we need to receive, we have like 24. And we need to get 12. So we need an x. So actually x will be, okay, so it's, I'm trying to transform division into addition. How many times do we need to add 2 to receive, to get 24? And this may work. I think this may work for this case specifically, but it will not work with zeros, because for zeros I'll need to do something else. Yeah, I guess for this one I give up. I'll try to look for a solution and try to understand the solution or discussion. Let me see discussion first. Maybe they will suggest something cool. Oh, take hint and solve by yourself. Take hint and solve by yourself. Computed value in ranges. Yeah, I would start, we'll first try, I guess, first approach. Okay, so for any nums I, calculate its left product and calculate its right product without including nums I. Oh, that's a pretty interesting hint though. Yeah, I mean, you try to explain this, but you used a bit of different words. I'm not sure I got it. And even now, I'm not sure I got it. So for any nums I, calculate its left product and calculate its right product. Okay, so but wait a second, how can I calculate its right product? Okay, so let's assume we are at index 0, so we have 1. We don't have anything on the left, we have on the right. So we kind of need to look forward. Or maybe I'll start, okay, so I have like a left, and I'll start at the first item, being 1, and I have a current. But I need as well next. So I'll need like 3 pointers. Okay, current being 2, and next will be like 3. So assuming we are at position 1, we start with the index 1. Left, there is none. Yeah, how to do that? Okay, so I'm a bit confused. So maybe too many. Okay, so left and right. Let's go with left and right. So the value for right will be 2. Left will be none. And current will be 1. Okay, so let's assume this. So for left we don't have anything. For right we'll have 1 multiplied besides that. Yeah, guys, today I'm not sure. I'm really stupid. For any nums I, calculate its left product and calculate its right product without including nums. Yeah, I really do not understand this. So you have some points. I am here. How to calculate its left product? Okay, so it's none. Let's pick another example, a simpler one. Left product. So for left product will be only this number. For right product, it will be these 2 numbers. So for each number here, so if I want to write it for I starting at 0, 1, blah 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 till n, this would be first part. Then I'll need to have like left part. This will be like a for loop. I need everything till this. For j, let's assume. For j till for j starting 0 till I do the sum, and I need another for loop for k starting I till n. So this will be for the right part. And how this is all fun, I don't get it. Maybe wait a second, because I mean I understand this. Okay, so you need to go from start to the middle and from end to the middle in the same time. Okay, I mean they are not related, so we can do right for k starting I till n. But still we need to do this operation for every item, so I do not see this in n of n time. Want to erase in one of them store a1 product of numbers in the left of nums I and iterated from 0 to n minus 1, and I took product of numbers in right of all of aj and iterated from n minus 1 to 0. Okay, so form two arrays. In one of them store a1. Guys, I understand all of this, but I do not understand how to write it linearly. You mean to do two prefix sums like I started at first? Because this is my trouble. This stuff, yeah, it's simple to work, but as you can see here, we have a nested loop. So this is not linear time. Right of numzi. Okay, so let's see what I easily can write it in two for loops in one way or the other. But I do not understand how to do it linearly. So I need it to one. So maybe for these values, I need to store them in some sort of but wait a second. Here comes my my idea first. Yeah, kind of now this makes a little bit more sense. So I go, yeah, kind of I think I got it. Because I can pre-compute this stuff. This stuff can be pre-computed. I have the prefix sum in right direction, in main direction, 1, 2, 6, and 24. And I go with the prefix sum in reversed order. And reversed order will be like this. Oh my god. Yeah, what will be the reversed order? Yeah, let me write it in this form. 4. Or no, maybe I do not need to write it in this form. Or do I need to write it in this form? Yeah, let me write just in reversed order. Will be like 4, 12, 24, and 24. So I have this pre-computed. So for j starting 0 till I, I being first, this would be the value. And for I being 0 till n, this would be the value, 24. So we kind of have we have our value, and this would be like the multiplication being like in this case index 1, where it will be like 1 multiplied by 24, and this works. So the first value works. Yeah, let's check for the second. Yeah, not sure. Guys, I just started my approach here and try to get somewhere. Because probably it has multiple solution, but I do not see yours. Okay, Krish, bye bye. Yeah, good luck on your exams. So, came back later. Yeah, bye bye. Okay, so let's assume we go to the second value. So second value being 2. What does it mean? So from 0 till I, 0, 1, we have this value 2. From I till n, yeah, I'm not sure I'm confused. Yeah, okay. Too much time spent for this one. Let's get a solution and then try to understand that part. So Rust, everything depends on zeros. Yeah, this is a bit too long. Extra space. Let's see this one. Let's see this solution and try to analyze this one. What does it do? Yeah, I could not solve it. Okay, so we have left value and we have right value. And we have a ret result, kind of. So we have a loop where we do, okay, so we start like with 2 pointers. Okay, so let's try to draw this. I think it will be more useful. So we have our results at first. Everything it's ones. Okay, I think I understand why it's ones, because we need to multiply things, and if you have zeros, then we got easily in troubles. So so this would be our results. It's called ret at first. We start with 2 pointers, left at 0 and right at 4. Okay, that's clear. And we have like 2 variables, left value and right value, where these are pointers as well. No, it's not pointers. Okay. Yeah, let me write them. So we have left value starting at 1 and right value starting at 1. So then we start looping. So we have I don't like the naming of this, but let it be. So we have this option like ret of L. What's the code? Yeah, multiplied by LV. Multiplied by LV. So LV it's 1 and this is 1. So at this stage we have 1. Okay, we do similar for right value. So let's have ret of right multiplied by LV. Let's have this in a loop. At this stage it's as well 1. So that's doesn't change anything. And now we do change the values for RV. So RV right value will be ret of L multiplied by LV. No, I think I'm confusing. So RV will be multiplied by nums of R. Nums of R. So I'll need nums as well. So let me add nums. 1, 2, 3, and 4. One, two, 3, and 4. So RV will be multiplied by. But wait, why? Okay, so nums of right, and then okay, LV will be nums of left. RV will be nums of I. Of right. And LV will be nums of left. And now we'll need to compute the L and R stuff. If R equals 0, break. Okay. If we do break this, yeah, I guess it was easier to go through. Okay, and we do that like right stuff +1 and left stuff -1. Yeah, that's an interesting concept. Yeah, I guess I'll use the debugger. I think it will be easier to see this. Yeah, I'm pretty sure you need to know a technique for this. Yeah, let's see first if this works. Okay, so this indeed works. And let me change a bit for the naming to result. Okay, so I have this result. Okay, L and R, it's clear. L and V, R and V, it's also clear. So this is like an approach on how competitive programmers do write the code. Like it's not production grade, but it's a way to fastly identify that. So yeah, this is just to not go beyond, to have boundary issues. And yeah, let's go with the debugger and try to understand how this algorithm works. Okay. Okay, so I think it's zoomed a bit too much. So we have this, we have result 1, 1, 1. So ref value, right, it's 4. Okay, and left value being 1. Because yeah, we have the pointers at 1 and last, so it will be 1 and 4. Okay. So probably I'll draw it here for now. So I have left value being 1 and right value being 4 for now. We go next, we decrement this 2. Now we'll do the manipulation of computing, because now left and right is different. So for left, we'll be increasing the last value being 1 multiplied by 1. Yeah, I guess when we record that's exactly what you were trying me to explain. but I'm not smart enough to understand that. so yeah. Now I see how to move at the same time. What did you mention last time to move at the same time? So this changes. This will become okay. So left value nums of. Okay. If you look at the result, this will become 2. Okay, so let me move this B. I don't need this, I just need this. Okay, so nums R and V. Okay, so result here being 4. Left value will change and right value change as well, because we have like this free part. Became 12. Left value we increase, we go. Right value. We go. Okay, so we got to 24. Now we got our result. Yeah, I mean it's a really cool idea though, and I'm not yet at that level to be able to come up with this idea right away though. Still a noob. Maybe in a year or two of practice. Yeah. Yeah, it's easy to spot them on how they name stuff because they don't bother to give like things to understand. I mean, this is good, but sometimes they just use like A and B, A1, AC, D. They don't bother at all to name properly things. But yeah, not sure. Either today is some sort of astrological thing where my mind is not working properly. Because even if I see it right now, I still cannot properly grasp what is happening. So yeah, let me check once again. I create a result at first where every item is 1. Okay, I can understand that why, because we need to multiply stuff. We start with 2 pointers in corners, left and right. And then we'll have like some left value, right value. This is troublesome for me. So what exactly do we store in this left and right? So we store some sort of pre-computed number. So yeah, let's go again with the debugger. It's tough to get smart. You need to pass through pain. That's, I guess, the quote of the day. If you want to be smart, you need to put your brain into a situation like this. So at first result, it's 1, 1. I guess nothing fancy here. Then we change. So we start adding our values like nums and left. So right value being the corners. So right will be 1 and left will be, right will be 4 and left will be 1. This is clear, and then we move the pointers closer to the center. I mean, we go towards center on both sides. Now we use the previous value, but left being, okay, so what's left? A left value being 1. Now left increased by 1, so we'll have like 2, and we store 2 in this case. Why it's not 2? Wait, left being 1. Result of L 1, left value 1. Okay, so here we sort the result. Okay, that's a bit confusing, but anyway, yeah, let's move on. Result of R will be R2 multiplied by 4. It will be 8. Right value. Wait a second, I don't get it. So where is the result of 2? Ah, okay, so it's a result of 2. Result of 2, it's 4. What's going on? 0, 1, 2. Yes, something weird here. I don't get it. Yeah, let me go with watch. That's why this is simple and genius. Yeah, I guess that's the reason. It's very simple and very uh, very interesting. Some sort of math plus technique, and yeah, indigenous. So we do change here, it being 8 and 12. Right being 0. Oh, so they kind of cross each other at some point, and they kind of multiply each other. Yeah, that's. I'm trying to visualize it at least to understand, because if now maybe I'll be able to write this algorithm, but I want to be able to do it in a couple of days. So that's the trick. So I need to kind of visualize it to have in my mind on how does it work. But not sure. But what's the problem? We can do it right now. I mean, I didn't see any trouble with this. Okay, yeah, this problem was tough for me. I mean, maybe it's easy where it's actually medium, but it was very tough for me to try to understand. So product of array except itself. And actually there is a YouTube solution, so maybe we can check
everyone, welcome back.
The solution in Python.
6 and the postfix, there are no, so we just assume that there's a 1 over here. So 6 times 1, this would be the output, the value that we would want to see if we could use the division operator for every single. So over here, we'd want the prefix of the values that come before it. And
yeah, I feel like he did go with
and then putting them in the output array. So now we're going to start at the end and go to the beginning and do the exact same thing, except we're going to be doing postfixes, which are basically postfix opposition in our result of I. We're not just going to be sufficient way to solve this problem. As you can see, best memory complexity, best time complexity as well. So I hope this was helpful. If it
yeah, that would be, I guess, different approach with the postfix and prefix. But that's for the other day. Yeah, let me try. I'm not sure if I want to submit it because I didn't solve it. Yeah, let me close this. It's just work. Yeah, sure. We can try to add your camera or something like this. Yeah, this is too smart. I mean, yeah, this guy, it's too smart. It's tough for me to visualize it, but anyway, it does work. That's good. So for that stuff, I see like this guy on leetcode.io, which started this problem. He suggests to go with the prefix and postfix stuff. So there is a solution for all those problems, and for troubles, we may try to go that way. But yeah, anyway, I guess I'll just mark it as reviewed. Let me publish it. What to do? I mean, I tried, didn't necessarily work. So copy and let's paste this here. And let's run. I guess it runs properly. And we'll get back in a year on seeing how to fix this problem. Valid Sudoku. Yeah, let me mark as checked. At least we checked it. Do we have more time? I think not for today. So I guess for the next stream, I'll do it on Tuesday. So I'll start with this one. So at least let's read it and try to understand what does it do. Yeah, I mean that's a good feeling. It's a bad feeling when I try to Maybe I'll get back next stream and I start writing the code with my initial idea with prefix sum and postfix sum going in both direction, because I didn't push enough to get a solution. So I got mixed into different kind of variation and didn't get to anywhere. Okay, so let's see what this stuff. Okay. Determine if a 9 by 9 Sudoku is board is valid. Okay, so this is a validation kind of. Only the filled cells need to be validated according to the following rules. Each row must contain the digits 1 to 9 without repetition. Each columns must contain the digits 1 to 9 without repetition, and each of the 9 3 by 3 sub boxes of the grid must contain the digit 1 through 9 without repetition. I have a feeling that I solved this one, or I did look into it. Let me check, because I'm pretty sure I tried to either solve it or already solved it. Alas, grep Sudoku. Let me see what do we have. Valid Sudoku. Yeah, I've looked a year ago. But not sure, did I solve it? Let me check if I solved it. Because yeah, it's pretty, yeah, it's working, so I did solve it. And I think I remember what I did. No, Fibonacci I don't think we need. I just did some tests. Is valid Sudoku, is valid boxes and the range records, and is valid rows, valid columns, and valid box. I guess, yeah, I kind of remember the approach. I check if rows, columns, and the box, I'm getting all the values, and then I do the validate function, which the validate function parses these things, then maps the numbers, collect the digits, forms a hash set out of it. I check the size to not be more than the number of them needed. Then I think I do a join of this this thing somewhere. Yeah, I'll check the range 1 and 9. So yeah, this is a kind of straightforward and boring, but not sure why it's not pasted. So probably yeah, let me check. Maybe I'll mark this as done right away. Validate. Yeah, let me see. That's hard one. Actually, it's not hard because yeah, I'll need the hash set part. I just need to hash set. I just need to get the values and then see if they are distinct or not. So probably it didn't pass at performance. No, it did pass at performance, and it's pretty fast. Yeah, let's go once again through what this stuff does, because it's kind of a lot of code, but it's nothing fancy in the end. So yeah, let me zoom this for you guys to see. So yeah. First, I need to know the number of rows and columns, and what I'm validating, it should be no less than 9 and columns no less than 9. If it's like this, it's false right away. Then I'll need to validate every row. So in order to do that, I have my board, and I'll pick all rows because I need it to be Boolean, and I'm calling this validate function. So for rows, it's quite straightforward because we have the row as a range of numbers, like being 1, 2, 3, 4, blah, 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 all these numbers. But even we do not know yet the numbers because I'm passing the entire row, which is a set of chars. So probably we should look at this validate function. So the validate function will pass this digit radix. We'll get only the digits. Then we'll transform those digits into numbers, and we'll collect those numbers as a hash set. Yeah, because I don't want to have like 2 3s, 2 4s. Yeah, I think so. It's I'm not sure if it's n cube. Yeah, it's n cube for the box part. But you know, if the Sudoku it's fixed size like 9 by 9, it's a constant time. So you cannot use n here. I guess n would be like the size of a Sudoku, but this is n by n, and that would be like a fixed size, so this will be like constant time execution. Even if you have 4 loops like this, it will be constant. So I'm doing this validate operation. So in order to check the distinct values, I do a hash set. And also I check the the hash set part, and also I check the range of the values because I want to be from 1 till 9. So I do check the size of the set and the range check. Maybe I should call it range check. Sudoku. So that would be the code to validate a range. And then here I do validation of the rows, and then this part we do validation of the columns. I need all the columns, so I will be getting the columns. So from 0 to columns, and I'll be pushing the board column row. I mean, this 2 for loops is just to get all columns. And then I'll be validating those columns. This would be the boxes. As you can see here, it's kind of hard-coded because it's a n by n, 9 by 9 Sudoku. And I do the similar thing for each box. I'll need first to get the values, the records. So instead of having like a box of 3 by 3, I will be flattening this into a vector of n or of 9 in order to use the same validate function, because logically it doesn't change anything. So the trick here is to get the values. So in the end, I need to return if all rows are valid, if all columns are valid, and all boxes are valid. So that was this problem about. So yeah, it takes some time to just write it, but conceptually it's quite simple. Oh, my wife has joined. So hello. I have looks like I have a new subscriber at last. My wife decided to subscribe to my channel. Okay, yeah, let's move on, I guess. So this is done. This I cannot solve. Longest consecutive sequence. Oh, this is another like common tricky one. This is another tricky one, and this is for sure for the next stream. Slash freebie. I kind of recall. Vlad, is it you? So welcome. A lot of people. I don't recall, Vlad. Is it your nickname? slash freebie. Yeah, that's good. We try to learn. Okay. So topics, hash table, union find. Yeah, probably we'll need to do a bit of research to solve this one, because I've looked into it, but I forgot how to do it. So this one and that one with the array stuff. So yeah, guys, probably I would still be around. So if you have any questions, because I see a couple of people joining in the chat. If you have any questions, I'll gladly answer. If not, I'll try to wrap up, and let's hear during next stream. Let me wait a bit for people to write the questions or discussions, because for this we'll need to look into what this union find does. This is a special technique. I mean, hash table I know, but union find I do not know. So yeah, probably I'll check this tag, and I'll need to union find disjoint set data structure or union find algorithm. So we'll need to learn about this. My god, it's insane how much publicity this Geeks for Geek uses. Okay, so what's the idea? What's a disjoint set data structure? Two sets are called disjoint sets if they don't have any elements in common. The intersection of sets is a null set. Okay, that's kind of understandable. A data structure that stores non-overlapping or disjoint subsets of elements is called disjoint set data structure. The disjoint set data structure supports following operation: adding new sets to the disjoint set, merging using union operation, finding representative of a disjoint set using find operation, check if two sets are disjoint or not. Consider a situation with a number of persons and the following tasks to be performed on them. Add a new friendship relation. Person X become the friend of another person, adding new elements to a set. Find whether individual X is a friend of an individual Y, direct or indirect friend. You're given 10 individuals, say A, B, C, D, E, F, G, Y, J. So A related to B, B to D, C to F, C to Y, J, Y, G. Given queries like whether is a friend or not, given queries like whether A is a friend or D or not, we basically need to create following 4 groups and maintain quickly accessible connection among group items: G1, G2, G3, G4. I feel like this is like heavily used in graph databases and graph structures. I would like to see you building a product like database in Rust on the stream, like a distributed databases. Yeah, that would be cool. I guess in time we'll get to building stuff, but I'll start first with smaller things. So one thing which I really want to do, it's this framework, Loco RS, and I want to build an app to value companies using like a valuation technique taught by Aswad Damodaran. So let me show you my guru in evaluation, sweat the mod run. Hope I'll not be banned that I leak other things. So he is a professor. I think it's New York University, and he teaches evaluation and finance stuff. So he has multiple courses. And now a couple of months ago, I guess a month ago or something, the valuation for undergraduates started. Also the MBA valuation for MBA started, and corporate finance started. And he stores all of his courses, past courses as well, for 2023. And he has a technique to value companies. And unfortunately, there is no like proper tool to use it. So I will try to build something to use his technique to value companies using this local RS. I even have a domain name, so this is called like stock perception. I started working on this project with a couple of students, try to do internship for them. So it's initial stages. But the idea here it's to do valuation for different stocks and make it public. Also to have like other people joining, doing their valuation, sharing their valuation, discussing. So having sort of community for value investment. So that's some plans which I have. But before that, I'll need to sharpen my algorithmic skills, because it looks like I'm not very good. So what it's supposed to do is to value companies. So for example, let's check Google, or let's say Amazon stock price. So you see, Amazon is sold now at $178 per share. But that's the price of the company. I want to do a valuation and see how much is really worth this company. So in order to value something, there are like three main components. You have the pricing part, so 178, but to value something. So let's go with a simple example. Imagine you have a chicken. Yeah, this is totally not related to programming, but it's related to finance, and I really like finance. So it costs 100, as I have a ton of people joining from India. Maybe there is some Indian guys in the chat. Let's call it rupees. So that's the price of a chicken. How do you come to this price? Yeah, so yeah, probably let's use the lei, MDL, because we are some sort of nationalist. Yeah, exactly. So I want to make a decision. Do I invest? Is it expensive or not? But the question is how. So a chicken, it's an asset. It produces something. So the product of a chicken will be an egg or multiple eggs. Yeah. So you know that in time, this chicken, so starting 0 and then to 1 year, 2 years, it will produce like 100 eggs, then 200 eggs. I don't know, maybe less, maybe more. So you know the price of an egg being like, I don't know, 1 leu or something like this. So you know that in 1 year you'll have like 100 eggs. But you also know, because it's more complex than that, you'll need to discount the result. But let's assume in 2 years you'll have like 300 total eggs. If it's 1 leu each egg, you'll have like 300 lei coming from this chicken. but this is in time. So this timing period, you'll need to discount to a specific rate. So this is called like intrinsic valuation of the company. So for this case, it's a chicken, but companies work similar way. So if it's a productive asset, you can value it. So yeah, you know how much will produce in time your chicken, and now you will pick a discount rate. And to pick a discount rate, it's not trivial. It's very, very tricky because it's influenced by risk-free rates, inflation, and so on. But let's assume I want 15% on my investment. So I will be discounting this 300 lei at 15% for 2 years. And this would be my present value of the investment. So present value at 15% of 300 lei will give my current price, which I should pay for this chicken. And in order to do that, you can choose Excel. So I guess simplest way will be to use Excel, and there is a function. So let me zoom it. It's called present value. So present value will provide the rate and number of periods. We'll be using years, so it will be like 2 years, and the current price will be 300. Actually, this will be like a future price. But wait a second. Yeah, okay. Yes, something looks like it's not right here. I'm not sure why do I get like 487. Okay, future value, no. I am... Oh, not this. Here I need to put 0 because I don't have payment amounts, so 300. Okay. So in order to receive like 15% on my investment, anything below this number would be like my profit. So I should be able to pay for the chicken 226, let's say, in this case it's dollars, but MD lei, and that would be a profit for me. And you do this for companies. This is called intrinsic valuation, and the technique is called discounted cash flow. And you'll be able to find and compare the price of the share with this value. And if this value is less than the price of the share, this means like the company would be a good investment for you. So that's the idea, and that's the product which I think on starting to work on building during next streams. So yeah, that's the idea. Okay, I guess that's it for the day, guys. Wish you a nice end of the weekend, and let's see how things will develop and continue with problems for now, because it looks like I really need to sharpen my programming skills with some problems. Yeah, bye bye.